So here I've got some polar grid here with some partially drawn polar function there. That is not intended to necessarily be a circle. Although if you wish to pretend that that's a circle, then that's fine. So my first question is, I've shaded a region in here. What shape is that shaded region?
Pizza.
Pizza. That's not the name of the shape. All right, this is not a circle here necessarily. Could be a circle.
Isn't it like an arc or a sector of a circle?
It is a sector. Yes, that is what it is. It is a sector of a circle. Now, it's not a sector of this thing, right? A sector, it has to be of a circle, but there's some way that I could follow this arc around so that I had a nice perfect circle here, and that this was exactly at the center of it, and this was a sector of that circle. And that's what this is. This is just a sector of a circle. And how do we find the area of a sector of a circle?
You divide the total area by the angle.
Yeah, we take the whole area, which would be pi r squared, and we multiply it by the fraction of the circle that we have, right? And so we have, how much of the circle do we have? We have some fraction out of a full circle, out of 2 pi. Yeah. And we would say that the fraction that we have out of 2 pi is the angle, right? What is the angle?
Theta.
Yeah, it's whatever this theta is. Well, that theta happens to be, we could call it theta, we could call it d theta. I'll call it d theta. And so if I were to sum together a bunch of these little tiny sectors of circles going all the way around, it would just be an integral of the area of one tiny fractionally, like infinitesimally small little piece of a circle. And so I would just integrate from one angle to another, alpha to beta, this whole thing right here. And what does this whole thing right here simplify down to? Looks like it's 1/2 r squared d theta, doesn't it? So all we have to do in order to find the area within a polar curve is do the integral from alpha to beta of 1/2 r squared d theta. Does that make sense to everyone? Remember, the summation is just let's sum together all of these things, right? This integral is just let's sum together all of the things inside of here from alpha to beta. So that's what we're doing, is we're summing together all of the areas of all of the sectors of the circles that could be drawn that are infinitesimally small from wherever we want to start to wherever we want to end. Good or no?
Yes.
Okay, so anytime we want to find the area between the origin and a polar curve, we're going to use this formula. Hold on 1 second. right, sorry about that. So here is the formula. It's yeah, we already had it written down, so we don't need to write it down again. Let's see if we can find the area of the region that is in the plane that is enclosed by this cardioid 2 plus 2 cosine theta. So first off, let's just real quickly think about what this graph looks like. Let's sketch the graph. Even though we don't necessarily have to sketch it, it's sometimes helpful to. If it's a cardioid, that means it's going to have that cusp at the pole, right? And which quadrants will this mainly be in? The biggest portion of it will be in which quadrants? Remember back at the beginning, like 7 weeks ago when we did polar coordinates? Anybody still there?
Could it be when cosine is positive, those quadrants?
Yeah,
So
be when cosine is positive, quadrants which?
which is 1 and the other one below it, which is 4, right?
Yeah, there you go. So it looks something like this, right? And we know it extends out to 4 units here. And so if we were trying to find the entire area enclosed by that, we would just want to integrate from where to where. How about from, well, where do you want to, where would we integrate from? Should be
0 to 2 pi.
0 to 2 pi, how to do it, right? So we're going to do an integral of 1/2 r squared, right? And what is r squared?
Four plus 4 cosine theta plus 4 cosine theta squared.
Yeah,
Or
I'm gonna write it.
squared theta, something like that.
So it's going to be this, and then we will go through and distribute that all out, which will be 1/2 of the integral from 0 to 2 pi of 4 plus 8 cosine theta plus 4 cosine squared theta d theta. Everybody good with that?
Why did we make the limits from 0 to 2 pi?
Well, we want the entire area of the region, and so going from 0 to 2 pi takes us all the way around.
Thank you.
Why is there 1/2 in the front again? Sorry.
Because of the formula we developed a minute ago, 1/2 r squared d theta.
I see. Thank you.
Yep, so there's 1/2 r squared d theta integrated from alpha to beta. Everybody good now or no? All right, so let's start integrating. So this gives us 1/2 of 4 theta, and then what about the 8 cosine theta? That should just become
8 sine theta.
plus 8 sine theta. And then we got a 1/2 and a 4, so that's just going to become a 2 integral of cosine squared theta d theta. And I should probably put my limits on here again. And what happens to the cosine squared theta? How do I integrate cosine squared theta?
Power reducing.
Power reducing formula. So we're going to have 2 theta plus 4 sine theta. If I distribute that 1/2 through from 0 to 2 pi. And then we're going to, the power reducing for cosine squared theta is 1/2 of 1 plus cosine 2 theta. So the 2 and the 1/2 will cancel out. So it'll become plus the integral of 0 to 2 pi of 1 plus cosine 2 theta d theta. Good or no?
Yeah.
And then we'll integrate the last part of it there. So we've now got 2 theta plus 4 sine theta. And then that 1 is just a plus a theta. And then we had a cosine 2 theta, which should become plus 1/2 sine 2 theta. And all of that's going to be evaluated from 0 to 2 pi. Good or no?
This is kind of small, but can we add the 2 theta and the theta?
Yeah,
Okay,
sure.
that's okay, right?
Yeah, that's fine. Yeah. And so now we'll just plug in our values. That's going to give us the 2 theta is a 4 pi. That's a 0 because the sine of 2 pi is 0. That's a 2 pi. And then sine of 4 pi is 0. And then minus. And then that's 0. And sine of 0 is 0. And theta is 0. And 1/2 sine of 0 is 0. So we just end up with it's like 6 pi units squared. Good or no?
Yeah.
All right. Any questions on that? That's about as easy as these will come. All right. Let's see if we can find the area of the inner loop of this limacone, 2 cosine theta plus 1. So what do you think the first thing that we should do is? Maybe sketch a graph of it. What should the graph look like?
Like a limacone with a inner loop.
Like a limacone with an inner loop. That's right.
I don't know how to describe it.
Let's start over here and come around and look about like that. Right? Starts 3 units over into the first and fourth quadrants area because that's 2 plus 1 is 3. Positive quadrants because cosine is positive. And the inner loop goes out to 1 unit there. Where does it start? What's the first value? If I plug in 0 for theta, it means that I'm starting at 3, which means I start here. And then which direction do I go? If I plug in, let's say, pi over 6, are we going to move this direction or are we going to move this direction? So the cosine of pi over 6 is a positive number times 2 plus the 1 is positive. So we're going to be over here at pi over 6, which means we're moving in this direction. And so that should help us to figure out exactly where this inner loop starts and ends, because it should start and end when our function has an r value of 0, right? That's when the inner loop should begin and end. And those are what are going to be our limits of our integration. So we got to take 2 cosine theta plus 1 and set it equal to 0, which ought to give us cosine theta equals negative 1/2, or theta equals what?
Two pi over 3.
2 pi over 3, and what else?
Um,
5 pi over 3.
Not 5 pi over 3. 5 pi over 3 is in the fourth quadrant. Cosine's
I
positive.
meant 4 pi over 3. Sorry, I added one too many.
You what?
Never mind. The way that I think about it is like adding 1 each time. I added 2 instead of. Never mind.
Okay. 2 pi over 3 and 4 pi over 3 sounds good. All right, so we'll do our integral should be from 2 pi over 3 to 4 pi over 3, starting and ending points of our inner loop. And it should be 1/2, and it should be r squared d theta. Good? So let's write all of this out. 1/2 of an integral of 4 cosine squared theta plus 4 cosine theta plus 1 d theta, 2 pi over 3 to 4 pi over 3. And now we should be able to integrate most of that, and we should be able to simplify the 4 cosine squared theta part of it down also. So what is this going to end up looking like? I'm going to do the second two pieces of it first. We got the 1/2, the 4 cosine theta. Oops, sorry, the 4 cosine theta gives us 4 sine theta. And the plus 1 gives us plus theta. And then the 4 cosine squared theta times the 1/2 gives us a 2 out in front. And then when we do the power reducing on the cosine squared, that's going to cancel out with the 2 because there's going to be a 1/2 in there. So we'll just have the integral from 2 pi over 3 to 4 pi over 3 of 1 plus cosine 2 theta d theta. Good or no?
Yep.
All right. And as we distribute this through, we're going to get 2 sine theta. We're going to get 1/2 of theta. And as we integrate this, we're going to get plus a theta. And then this one will be a plus a 1/2 sine 2 theta. And all of that gets evaluated from 2 pi over 3 to 4 pi over 3. And what's the sine of 4 pi over 3?
Negative root 3 over 2.
Negative root 3 over 2. And if we multiply that by 2, that's just negative root 3. And then 4 pi over 3 divided by 2 will be 2 pi over 3 plus 4 pi over 3. And then 1/2 the sine of 2 theta. So sine of 2 theta means the sine of 8 pi over 3, which is the same as the sine of 2 pi over 3. What's the sine of 2 pi over 3?
Root 3 over 2.
Root 3 over 2, and then so half of that will be root 3 over 4. And then we will subtract, evaluating this at 2 pi over 3. So what's the sine of 2 pi over 3 times 2?
Root 3.
Should just be root 3. Yep. And then half of 2 pi over 3 equals plus pi over 3. And then plus 2 pi over 3. And then the sine of 4 pi over 3, like we said before, is negative root 3 over 2. And half of that will be minus root 3 over 4. And what does that simplify to? We got 2 pi over 3 and 4 pi over 3 is 6 pi over 3, which is 2 pi. And then we're going to subtract pi, so that'll be pi. And we got negative root 3 minus another root 3 is a negative 2 root 3. And then we got negative 2 root 3 plus root 3 over 2, which is going to be a negative 3 root 3 over 2. Everybody agree with my arithmetic there? Yes, no, maybe?
Yeah.
Yeah? Wonderful. All right. Let's take a look at another one. Let's make it a little more complicated. We want to find the area of the region that is inside the circle r equals 1, but outside the cardioid r equals 1 minus cosine theta. So what do you think we're going to need to do here? First, let's shade the region. How about that? All right. what region is that? Outside of the circle? Oh, sorry, inside the circle, so inside of here, but outside the cardioid should be this section right here. True?
Yep.
Okay. And then how are we going to figure out where to integrate from? From what angle to what other angle?
Find where they intersect.
Okay, find where they intersect. And so how do we find where two things intersect?
Set them equal to each other, but also the graph shows where they intersect.
Right, it shows us, it does show us the places, but it'd be good to show the work. R equals 1, I'm sorry, not right, R equals 1. R equals 1 and R equals 1 minus cosine theta, so just do 1 equals 1 minus cosine theta. And that tells us cosine theta equals 0, which would be at theta equals pi over 2, and at 3 pi over 2, and so on and so on. Every pi after that, but we don't care about those. We just care about pi over 2 and 3 pi over 2. And so where do we need to integrate from? That's the question here. And this is where these start to become a little bit trickier when we have two different functions that are overlapping each other.
Is it from 3 pi over 2 to pi over 2?
Right, and so there's a problem with doing 3 pi over 2 to pi over 2, right? Because that's going from here to here, but that's really not where I'm going from. If I'm going from 3 pi over 2 this direction to somewhere, I'm going from 3 pi over 2 to 5 pi over 2, aren't I?
Would you
Should we make two different limits? Or sorry, two different integrals?
Okay, so we don't necessarily have to do two different integrals. But first off, do we see why going from writing 3 pi over 2 to pi over 2 is an issue? Because these things are getting traced this way. So by the time I get to 3 pi over 2, I'm not going back to pi over 2. I'm going back up to 5 pi over 2 for the second rotation around it. Does that make sense to everybody?
Yeah.
Okay.
Can you just do negative pi over 2 to pi over 2?
All right, so one option is we can do negative pi over 2 to pi over 2, because negative pi over 2 is also a value in here. So I can put that in there. Negative pi over 2 is a value also. So we could go negative pi over 2 to pi over 2. Or if we didn't want to do that, what do you know about both of these? They're both symmetric across the polar axis. So I could just go from 0 to pi over 2 and do what with that?
Multiply by 2.
I could just do that and multiply it by 2. Exactly. So what do you guys want to do? You guys want to do negative pi over 2 to pi over 2? Or do you want to do 0 to pi over 2 and multiply it by 2?
0 to pi over 2.
Okay. All right. So let's do 0 to pi over 2 and then double it. Everybody sees why that's a thing that we could do?
Yeah.
Okay. So we will do 2 times the 1/2 of the integral from 0 to pi over 2 of our r value. Well, what's our r value?
Just what would be the circle minus the cardioid?
It should be the circle squared minus the cardioid squared. So we got to make sure that we do each one of those separately. 1 squared minus 1 minus cosine theta squared, but not 1 minus 1 minus cosine theta squared, because that's different. Okay. So we're looking for the area inside the circle, and then minus the area of the cardioid. Everybody good with that? Hopefully.
Yeah.
Okay. And so the 2 and the 1/2 should cancel out, and that should leave us with just an integral from 0 to pi over 2 of 1 squared, which is 1, minus all of this junk. So 1 minus 2 cosine theta plus cosine squared theta d theta. And that should give us what? The integral from 0 to pi over 2. The 1 minus the 1 should cancel out, and we should be able to distribute that negative through to everything else. I think that was what? 2 cosine theta minus cosine squared theta d theta. And you can do the 2 cosine theta right off the bat. What does that become? Should be 2 sine theta. And then it should be minus 1/2 the integral from 0 to pi over 2 of 1 plus cosine 2 theta d theta, which is going to give us what? 2 sine theta. I should put that up here, like this. So 2 sine theta, and then what? Minus
1/2 theta, and then minus
theta
1/4 sine 2 theta.
minus 1/4 sine 2 theta. Everybody good with that? And that's from 0 to pi over 2. Good or no?
Muy bien.
All right, and the sine of pi over 2 is 1, so that's 2, minus pi over 4. Double pi over 2 is pi, so that's minus 0, and then minus 0 minus 0 minus 0. And we end up with 2 minus pi over 4. Good or not good or something? Any questions, any issues with that?
So when you were saying that like it's always traced in a certain direction, like that, like it's always going the counterclockwise, or
Well, it's not always going counterclockwise. It just depends on, you gotta take a look at what it's doing. Generally, they're going to go counterclockwise, but if you like throw a negative sign in there, sometimes that can change the direction in which they're going. But for the most part, yeah, counterclockwise.
okay.
You can always just test, figure out where it starts at 0 and then try one more value after that and see which way it's going. So,
I see.
all right, let's take a look at another one. I'm going to give you guys a couple of minutes here to try and work through this one on your own once we sort of talk about how to get it started. So we've got the area outside the circle, but inside the cardioid. So we're talking about all of this. Okay. And how are we going to figure out where to integrate from?
Set them equal to each other so that we can find the intersection points.
Right, set them equal to each other. So here's what I will let you guys do. I'm going to give you guys about 4 or 5 minutes here. And I want you guys to solve that, see where they intersect, figure out those points, and then determine how you think the best way to go about setting up those angles are, and then integrate it and see what you get. Probably it'll take you about, I would guess, at least 5 minutes. Sound good? You guys all think you could make a reasonable attempt at that?
Yeah.
All right, you got 5 minutes-ish. Ready to go. Okay, so first off, we solve this to get sine theta equals -1/2. And that gave us theta was what?
7 pi over 6 and 11 pi over 6.
7 pi over 6, 11 pi over 6, and so on. And if we wanted to include some negative values, we'd include negative pi over 6 also within there.
Indeed.
Okay. And then so we determined, hopefully, that where does this start? If theta equals 0, this should start over, this one starts here at r equals 2, and it's going to go counterclockwise. And the other should start here at r equals 3, and it's going counterclockwise also if you plug something in. So we want to go from here to here. So what are two consecutive angles at which they intersect, starting here, going this direction?
Negative pi over 6 to 11. Oh, sorry, 7 pi over 6.
Negative pi over 6 to 7 pi over 6. So I think those would be the best two options. Now you could start at 11 pi over 6 and then go around to, what is it, 19 pi over 6. But I think negative pi over 6 to 7 pi over 6 will work out better. Just a little bit easier. So we're
Could you
gonna
also do?
say that again?
Could you also do 2 times the integral from negative pi over 6 to pi over 2?
You could, yeah. Yep, that'd be fine. Is that what you did?
Indeed.
Yeah, that's fine. I'm going to put it in with negative pi over 6 and 7 pi over 6, just because we did the last one with the doubling up, but it doesn't really matter. So we have 1/2 of the integral from negative pi over 6 to 7 pi over 6 of the outer radius squared. So our outer radius here is the one that comes from the cardioid. So that'd be 3 plus 2 sine theta squared minus the inner one, which is 2 squared. Good? Or no?
Yeah.
All right. And so we're going to end up with a 9 plus a 4 sine theta, sorry, plus a 12 sine theta. So let's put in the 12 sine theta. So we're going to have a 12 sine theta. We're going to have a 9 and a minus 4, so that's going to be a 5. And we're going to have a 4 sine squared theta. And 4 sine squared theta should be 1/2 of 4 times 1 minus cosine 2 theta. So that's going to be what? Another should be another 2, positive 2 minus 2 cosine 2 theta. So we can make that 5 turn into a 7. So plus 7 and then minus 2 cosine 2 theta. Everybody good with that?
Yes.
Cool. All right. And now we just need to integrate. So we will have 1/2 of, let's see, we had a 7, right? So 7 theta. We had a, what do we have? We had a 12 sine theta. So that'd be minus 12 cosine theta. And then we had a 2 cosine 2 theta, or was it a negative 2 cosine 2 theta? Negative 2 cosine 2 theta. So that'll be a negative sine 2 theta. Everybody good with all of that or no?
Yep.
All right, and now we just evaluate. So we got 1/2 of 49 pi over 6 minus, what's the cosine of 7 pi over 6? That should be a negative root 3 over 2 times a 12. Should be what? Negative 6 root 3 over 3, right? Plus the 6 root 3 over 3. Or 6 root 3 over 2, so 6 root 3. Yeah. And then minus sine of 14 pi over 6. What's the sine of 14 pi over 6?
Square root 3 over 2.
Yeah, it should be square root 3 over 2. And we got, that was a minus, so minus root 3 over 2. And then minus, that's going to be a negative 7 pi over 6. And what's the cosine of negative pi over 6?
Square root 3 over 2.
Root 3 over 2 times 12 should be minus 6 root 3. And then the sine of negative 2 pi over 6 ought to be, should be a negative root 3 over 2. So plus root 3 over 2. Put the negative in front. And then just simplify it down. What do we end up with? 49 pi over 6 plus 7 pi over 6 is 56. That's what, 56 pi over 12, which should reduce down to 14 pi over 3. And then 6 root 3 or 6 root 3 plus another 6 root 3 is 12 root 3. And then 12 root 3 minus root 3 is 11 root 3, and then over 2. So plus 11 root 3 over 2. Is that what you guys got?
Yep.
Cool. And you, I think, no, you said you did it with the negative pi over 6 to pi over 2 and doubling it, right? Came out the same. That probably, arithmetic probably came out a little easier that way.
It did.
Yeah. So either way is good. Any questions on that?
Could you go back a slide?
Sure. Let me know when you're good.
Oh, okay. I got it. Thank you.
All right. Everybody good with that or no? I'll take that as a yes. All right, next one. Very similar. Except what is it asking for this time?
Inside the circle and outside the cardioid.
Okay. So which region are we looking at? We're looking at this bottom region right here, right? And so how is this going to be different?
We probably want to be going from 7 pi over 6 to 11 pi over 6.
Exactly. So we're going to do 1/2 of an integral from 7 pi over 6. And this time, why don't we could just do the 3 pi over 2 and double it. That might make things a little bit easier this time. Everybody good with doing that? Since these are both symmetric across the line theta equals pi over 2. And this time, which is the outer function? It should be the circle, 2 squared, minus the inner function, 3 plus 2 sine theta squared d theta. Good or no?
Good.
All right. So the 2 and the 1/2 ought to cancel. And so we're just going to be left with an integral from 7 pi over 6 to 3 pi over 2 of, let's see, this is going to be 4 minus 9 plus 12 sine theta plus 4 sine squared theta d theta, which should become the integral from 7 pi over 6 to 3 pi over 2. We're going to have a 4 minus the 9 is going to be a -5. And then minus 12 sine theta. And then minus 4 times 1/2 times 1 minus cosine 2 theta d theta. And so if we put all that together, the -4 times the 1/2 should be a -2. So we should end up with a -7 there for our integral. Everybody agree with that? Is the constant in there?
Yes.
So we got -7, we got -12 sine theta, and we've got a +2 cosine 2 theta. Everyone good there? Hopefully. And so we should end up with -7 theta. And then that should become a +12 cosine theta. And what was the last part? The +2 cosine 2 theta, so just a plus sine 2 theta. And we'll be evaluating from 7 pi over 6 to 3 pi over 2. Sound good to everybody?
Sounds good.
All right. Now what? 3 pi over 2 times the -7 should be what? That should be -21 pi over 2. And then plus, what's the cosine of 3 pi over 2?
0.
0. And what's the sine of 3 pi?
0.
Another 0. Minus, now we'll evaluate all this at 7 pi over 6. So that's going to be minus a -49 pi over 6. And then cosine of 7 pi over 6 ought to be what?
-√3 over 2.
-√3 over 2. So that'll be -6√3 there. And then the sine of 2 times 7 pi over 6, that's the sine of 14 pi over 6, or the sine of pi over 3, which is +√3 over 2. Everybody agree there?
Agreed.
All right. And what do we end up with? Should end up with, if we get a common denominator there, that's going to be a 6 for those. And what do we get? We get -63 plus 49 over 6. So that should be -14 pi over 6 or -7 pi over 3. And then we got a +6√3 minus a √3 over 2, which should be plus 11√3 over 2. Good or no? Any questions, any issues? We doing okay or no? Yes, no, maybe.
Doing okay.
All right, let's do another one. And same two equations. Now we want the area that's inside the circle and inside the cardioid. So now we're looking for this section right here. So take a look at that for a second. Do you see any good ways to get that?
Would we need to do 2 integrals?
Well, we might need to. In fact, I guess the right answer is, yeah, we sort of need to.
We could just do the circle minus the integral we just found.
Yeah, we could do, if we didn't already have the integral we'd already done, we'd have to find that integral and then do the circle piece. But if we know what the full circle is and we already know what we just did, let's call that the section in blue. All we're looking for is the red. The red is the circle minus the blue. and the blue is what we just did. So what's the area of this circle? Should just be pi times its radius squared, right? 4 pi minus whatever we just had, negative 7 pi over 3. So plus 11 root 3 over 2. Which should give us what? 4 pi plus 7 pi over 3 is going to be 20. No, not 20. No, yeah. I can add 19 pi over 3. And then minus 11 root 3 over 2. And there's not really a good way to do this one without finding some other integrals first, unfortunately. Right, so luckily we'd already found these other integrals for this bottom piece and this top piece. Because we could have done the full cardioid, right, minus this outer piece that we'd already done, or the circle minus this little inner piece there that we'd already done. Either of those would have worked out nicely. But there's not a good way to just go from here to here and figure out this specific area without doing one of those other ones first. Because sometimes the outer portion of it is the cardioid and sometimes it's the circle. You guys all see that? Does that make sense or no? Are we good or no?
Yeah.
All right. Cool. All right, we got one last problem today. Last one for the day. Let's see if we can find the area that is enclosed by one petal of the rose curve. So how are we going to do that? Thoughts?
Could draw it out first just to see what we're doing.
Okay, so we should know vaguely what this looks like, right? It's got how many petals?
4.
4, and it's cosine, so it's going to start along here. So we know it's going to look like this. We just need one petal of it. So we just got to figure out, we could even just do half of one petal, right? And then multiply that by 2. So if I plug in 0, that's going to put me here. So then I just got to figure out when does r equal 0. When's the first time after 0 that r equals 0? And that should tell us that the cosine of 2 theta is 0. And when does that happen? When 2 theta is pi over 2 plus every pi n. And so that would be theta would be pi over 4 plus pi n over 2. And when n is 0, that's just pi over 4. So we could go from 0 to pi over 4. And we could double that. Yeah, that should be one petal of it. Or alternatively, we could go from negative pi over 4 to pi over 4. Or we could go from pi over 4 to 3 pi over 4. Or from 3 pi over 4 to 5 pi over 4. Or you could do, pi over 4 to pi over 2 and double it. Any of those would all work. So what do you guys want to choose to do?
I think going from 0 to pi over 4 and doubling it would be best.
All right, so let's do that then. We're going to do 2 times 1/2 of the integral from 0 to pi over 4 of our r value squared. So 4 cosine squared 2 theta d theta. And the 2 and the half will cancel.
Don't you have to square the 4 too?
Oh, yeah, I should have. 4 squared cosine squared 2 theta. Sorry, I don't know what I was doing there. And so what does that give us? these cancel out. The 16 can come out to the front, right? And if the 16 comes out to the front, when I simplify down this cosine squared, it's going to get another 1/2. So that's going to put an 8 out in the front. So we're going to have 8 times an integral from 0 to pi over 4. And then the simplification for cosine squared 2 theta should be 1 plus cosine 4 theta d theta. Everybody good with that or no?
Yeah, good.
Okay, and so we'll just integrate. So we got 8, and then we got, let's see, we had theta, right? And then the integral of cosine 4 theta should be 1/4 sine 4 theta. And we're going to go from 0, what was it, 0 to pi over 4, right? And so that ought to give us 8 times pi over 4. And then the sine of pi over 4, sorry, the sine of 4 times pi over 4 is the sine of pi, which is 0. And then minus 0 plus 0. And we end up with just 2 pi. Good or no?
Beautiful.
Great. That's area using polar coordinates. There's not really anything else to it. Pretty straightforward. A lot of trig integrals, a lot of power reducing formula. Good or no? Everyone's good? Everyone feels all right about that? Yes, no, maybe?
Yes.
Oh, good. All right. It's hard to tell when like people don't answer. So that's it for today.